Today we're talking about subtracting real numbers. The problem with the concept of subtracting real numbers is it's actually a misnomer because we don't really subtract real numbers. Subtraction doesn't really happen. What we're doing when we say subtract is we're actually adding the opposite. So when we say 5 minus 3, what we're really doing is adding 5 and the additive inverse, or the opposite, of 3. So subtraction doesn't really happen. Addition does. We just teach subtraction to younger kids because it's easier to understand starting with 5 and taking 3 away than it is to understand starting with 5 and adding a negative number. But when we look at it as addition, and we look at it in light of yesterday's lesson, it makes this a little more clear. For instance, when we start with negative 12 minus 19, we can look at this as the addition of two negative numbers, negative 12 and negative 19. And I know how to add two negative numbers. When they have the same sign, I add and I keep their sign. And so the result is negative 31. The other place this is helpful is when I have something like 18 minus negative 7. So subtraction, since subtraction means adding the opposite, that means I'm taking 18 and adding the opposite of negative 7, which is positive 7. And that's simply 25. If I looked at that as a subtraction problem, I might have a difficulty with it, but when I rewrite it as addition of the opposite, it makes a little more sense. Why don't you try these two yourself and see what you come up with. We'll pause the video, give you a little bit to come up with an answer, and then we'll come back with an explanation. Okay, so the first one is negative 2 plus negative 7. Since they have the same signs, we add them and keep their sign. For the second one, we remember that subtraction means to add the opposite, and the opposite of negative 5 is positive 5. So now I'm simply adding two positive numbers, which gives me 16.7. Now, let's throw some variables in here. We're going to be asked to evaluate the expression y minus x plus 6.8 when x equals negative 2 and y equals 7.2. Now here's where we have to be careful is when we start to mix signs in, because we can lose a sign or gain a sign and end up going positive when it should be negative or negative when it should be positive. So when I plug in my values, I'm going to make sure that I put them in their appropriate place in parentheses. So I put 7.2 in for y. Then I'm going to subtract x, and x is negative 2. Then I'm going to add 6.8. And so now I see that when I'm subtracting x, I'm actually adding a positive 2 instead of subtracting or adding a negative 2. So I've got three positive numbers, and all I have to do is total them up since they all have the same sign. And when I do that, I get a total of 16. Why don't you try one of those yourself? How about y minus x minus 2 when x is negative 3 and y is 5.2? We'll pause the video and give you a chance to try this. Okay, so what I want to do is I want to put in that 5.2 in parentheses for y and the negative 3 in parentheses for x. Now, I want to do what's inside the innermost parentheses first, so I'm looking at this one because there's nothing to do in the first set of parentheses. So I'm going to rewrite that as addition. So I've got negative 3 plus negative 2. Since they have the same sign, what do? Right, I add them and keep their sign. So now I've got 5.2 minus negative 5. So I'm going to change that to an addition problem. 5.2 plus the opposite of negative 5, which is positive 5. Now I've just got two positive numbers, so I can add them and keep their sign. Let's combine this with a function. In example 3 in your book, it says one of the most extreme temperature changes in United States history occurred in Fairfield, Montana on December 24th, 1924. The temperature at noon was 63 degrees Fahrenheit. By midnight, the temperature fell to a ridiculously cold level of negative 21 degrees Fahrenheit. So the question is, what was the change in temperature? Now, we're going to look at this analytically as a math problem, and then we're going to look at it a little more logically and see what we come up with. So first of all, we want to find the change between the two. And so when we're looking at change, we take the new minus the old. And so the new, in this case, is the later temperature, which is midnight. So we have negative 21, and the old is the earlier temperature, which is noon, minus 63. So we're taking negative 21, and we're adding the opposite, negative 63. So since they have the same sign, we can add them together, and we can keep their sign for negative 84. What does it mean that there was a change in negative 84? Right, the temperature dropped 84 degrees. That's quite a change. So we could say it dropped 84 degrees, or it was a negative 84 degree Fahrenheit change. Now let's think about this logically. From noon to midnight, it dropped from 63 to negative 21. So first it had to pass 0. That's a drop of 63 degrees. Then it had to pass from 0 to negative 21. That's a drop of another negative 21 degrees. And so when we total that up, we see again that we get negative 84 degrees Fahrenheit for change. That is really, really cold. Okay, let's try this one on your own. A new car is valued at $15,000. That's not a bad deal, depending on the type of car. 1 year later, so it's a year old now, the value is $12,300. So using that same concept of change being new minus old, take a minute and figure out what the change in value of the car is. Okay, now our new value is actually 12,300 because that's the most recent value. We're not talking about new as in a new car. We're talking about new as in most recently. So we start with 12,300 and we subtract what we started with, 15,000. So we know that that means to add the opposite. And when we're adding the opposite, we're going to do 15,000 minus 12,300 and keep the sign of the bigger number. So we get a change of 2,700, and since it went down and since our bigger number is negative, we know that it's a change of negative $2,700. All right, that concludes the lesson for today. If you have any questions, feel free to ask. You can watch the video again if there's something you need repeated, or you can move on to your homework.